was out in the woods last week. Did anything happen? You know, the sad thing is, even out in the woods, somehow the news follows you around. And so I know all too well what happened. All right. So my job, I was told quite clearly that I had to go through the basic science fundamentals. I said, really? And I know a good number of people in this crowd, and I know most of them don't need this, but I'm going to obey, as I do well most of the time. So here's a fast summary of the scientific underpinnings of this whole issue, and those of you that have heard me speak before can have a little nap until the last slide. I found this image to convey an incredibly important fact about the proportionality of the world's climate system. And basically the deal is, you see how big the Earth's surface is, and then how absolutely tiny the atmosphere is. This gives you a sense that you think the atmosphere is only about 10 miles thick. That's like here to Lolo, or here to Frenchtown. And so this idea that we can fill up the atmosphere with pollutants, once you understand this proportionality, you go, yeah, that wouldn't be hard at all. And it's certainly exactly what we're doing. This tiny little ribbon of atmosphere around the world just is being used as a garbage can, and it's filling up, and we know it. And here's how we know it. An old Montana resident, Dave Keeling, started the famous Keeling curve in Mauna Loa in 1958, measuring CO2 in the atmosphere. And as you can see in the inset graph up there, ever since he started measuring, it's been going up every single year. There's not been one year that it went down. And we now have this same measurement in at least 40 or 50 places around the world. This is replicated all over the world. There's no argument at all that CO2 is going up in the atmosphere. And the consequences of that we've also known for over a century. Svante Arrhenius thought this through in 1896. That as society was starting to burn coal for heating in London, he said, well, that puts CO2 in the atmosphere. CO2 acts as a greenhouse gas. I wonder if someday it'll warm the earth up. He figured this out 100 years ago from just raw intuition. And I find it amazing how many people still think this is some mysterious theory that's unfounded. It's been around a long time. And the physics is really airtight. For those of you that don't read Ipcc reports, and they average 2,000 pages in length, and so I have to say I've never read one either. I read my chapter. I read a couple of the other chapters. No, I don't know if any human has read a whole one. Probably some intern, you think, somewhere is required to. So here's the one-page summary of an Ipcc report. And it's basically adding and subtracting what we call the radiative forcing of solar energy coming from the sun and how it's interacting with the climate system. And basically everything that's red warms the system, and everything that's blue cools the system. And you can see, let's start at the bottom is easy. One of the ideas is the sun might be getting brighter. Well, it's getting about that much brighter, to be exact. We measure it quite well. The reflectivity of the Earth's surface, could that be changing? Yeah, it could. It's changing about that much. And we can go right up there looking at our measures of aerosols, of cloud cover, of short-lived gases, and then, of course, at the top, the big ones, the long-lived greenhouse gases. And you can see Carbon dioxide and methane are by far the big ones. And these are measurements. These aren't computer models. These are measurements taken all over the world. And you add and subtract all the pieces, and here's the bottom line. 2.3 watts per square meter. Now, probably none of us can relate to that just intuitively, but imagine a Christmas tree light right over this table. This table's pretty close to a square meter. And imagine one Christmas tree light on this square meter, and another little Christmas tree light on the next square meter, and the next one all around the whole world. Every square meter is getting one Christmas tree light of additional energy being trapped. And that's the greenhouse effect right there. That's our measurement of the amount of additional heat trapping. And don't use an LED bulb for this. Use them for everything else. But for this example, you have to go back to the old ones. But that's a good way of getting a mental picture of what we're talking about, of the energy being trapped, is a Christmas tree light per square meter around the whole world. And this is what the 2014, the newest Ipcc report, is the sum calculation of global warming. And so you can see we know both the warming and the components of it really pretty well. We also know where it's going. And this one surprises a lot of people. And again, until you think about physics, I'm sure you've all had physics in the last 5 years or so. Imagine, you remember the difference in heat capacity between air and water? Just in a general sense? I don't, but I can kind of imagine it. I don't remember much anything anymore. What we know is now 95% of that 2.3 watts per meter squared is going into the ocean. What's amazing to people is here's where we see the illustration how little the atmosphere matters to climate, is that energy going to the atmosphere and land combined is only about 5%. So most of this is going into the ocean. The atmosphere delivers the final result in day-to-day weather, but the climate as a system is driven more by the ocean than anything else. And this is very clearly shown by this data set. The other thing I always find useful with this one, look when this started. This ramp up started about 1980, about when I got here. So really my whole career here, global warming's been underway. We didn't really know, yeah, it's probably my fault. We couldn't really see it until about 2000 when we looked backwards. So it took us a while to realize that this was a signal that was going to continue. But if people think that global warming is something new that's just starting up, we have abundant evidence that it's been going on the order of 40 years already. And of course, it's clear the temperature, the resulting global temperature increase. This is the decadal averages, and you see they just keep marching since 1980 up every decade. You probably have heard that the last 3 years in a row we've set all-time global air temperature records, third straight year. And so the consequences that theory expects of trapping all that heat are showing up in the atmosphere, sure as you would expect. No surprises. One summary, because I have lots of other experts that are going to go to details. The one summary that I want to zoom in here to have us think about is what's really going to make the difference on how livable Montana is really going to be our water balance. And what we've calculated is with the increasing temperatures, we need to be adding about an inch per decade to our annual precipitation. And so like right now, Missoula averages about 14 inches. In a decade, we would need 15 inches, in another decade, 16 inches. And as Nick's going to show you, it's not happening. So we are getting the temperature increase, but we're not getting the additional precipitation. We're aridifying, and you'll hear more about that soon. I want to touch on a little bit about what we know of global emissions. This is by nation, the top fossil fuel emitters, India, EU, US, China. I think it's worth pointing out that the US's emissions peaked 6 or 8 years ago. A lot of people don't know that. But we've actually turned a corner, despite what a lot of people have to say. We think that China is leveling off. So we are seeing some pretty tangible early signs of slowing down of carbon emissions, and this is showing up in the data. The other thing that's important to recognize is by far the biggest culprit is coal. And you see particularly this spike of coal burning of the last 15 years is what really blew global emissions over the way it had. And this is why I basically every public talk I give, I use this slide. That if we don't quit burning coal, nothing else we do matters. Simple as that. Now we are doing a lot, and the employment in the solar industry is marching up. It's about triple what the employment in the coal industry is now. We all know wind power has really reached a market penetration that's substantial. And the big thing I want us to think about is here that this is the climate model projections to the end of the century. So here we are, right here, 2017, and here's the normal chatter of year-to-year temperature anomalies. The projections with business as usual take us up into this sort of temperature range. This is for Montana, and you see this is on the order of a 12 to 14 degree increase by the end of this century if we continued with our fossil fuel energy economy. So all of the policy and politics about climate change are about driving the emissions down to drive this temperature down. Now the Paris Accord was negotiated around about a 2 degree temperature increase, which takes you to right about there by the end of the century. And so that's what the Paris Agreement has had what was agreed upon. And of course, we all know what happened last week. This is what happened about an hour ago. I got an email in my office on a website we are still in, and it's an open letter by 1,000 mayors, governors, corporate leaders, academic and university leaders, basically an open letter to the rest of the world saying that we don't particularly care what President Trump announced last week. We're still in. I've never seen anything like this in my life.